Okay ji, welcome to the next topic of theory of computation. So we continue with the concatenation of finite automatas. Another example, build finite automata corresponding to the concatenation of these two FAs, that is FA1 and FA2. So we have the regular expression corresponding to FA1, which may be written as A plus B into B and A plus B star with B as a second letter. It is the same as we discussed in the slides previous as one. And the second one is regular expression corresponding to FA2, which may be written like this with odd number of A's. So these are the two diagrams for FA1 and FA2. So we developed the table for it. हमारे पास x1, y1 चूँकि दोनों starting state हैं, तो we have the z1 as the starting state corresponding to x1, and reading A and B we reach to new states. So as x2 equal to z2 is the same state after reading A, so after reading B it will be the same state. Similarly, we develop the other states like this as well after reading A and B. So we have the diagram correspondingly like this. Z1 is the starting state and Z5 is the ending state. Z5 is the ending state because in the previous diagram Y2 is the final state. So if Y2 is present, that will represent the ending state now. If at the initial state of the given finite automata there is either a loop or an incoming transition H, the initial state corresponds to the final state and the non-final state as well of the required FA. Otherwise, the initial state of the given FA will only correspond to a single state of the required FA. Another example, build an FA corresponding to the closure of the following finite automata. So here Y1 is the initial as well as the final state. NFA. An NFA is a transition graph with a unique start state, only one, and a property of having single letter as label of transitions. An NFA is a collection of three things: finite many states with one initial and some final states, finite set of input letters like A, B, C, etc., finite set of transitions showing whether to move if a letter is input a certain state. Lambda is not a valid transition. There may be more than one transition for certain letters, and there may be any transition for certain letters. It may be observed from the definition of NFA that the string is supposed to be accepted if there exists at least one successful path and otherwise rejected. Also, an NFA can be considered to be an intermediate structure between FA and transition graph. The examples can be found in the following. Now this is an example. 1 is final state, 1 is the initial state, 2 is the final state, 5 is the final state, 3 and 4 are intermediate states. It is to be noted that the above NFA accepts the language consisting of A and AB. 1 से 2 तक A, 1 से 5 तक AB. Also, above NFA accepts the language of string defined over sigma AB containing double A. 1 से 2 तक A, 2 से 3 तक A. NFA helps to eliminate a loop at certain state of a finite automata. This process is done converting the loop into a circuit. But during this process, the FA remains no longer FA and is converted to a corresponding NFA. Another example, with an alphabet sigma equal to ABCD. अब हमने eliminate करना है loop को at state 7. So the corresponding NFA will be as follows. So you can see that we have developed a state like this. तो 7 की जगह हमने 7 और 11 कनेक्ट कर दिया. 7 पे चूँकि लूप था तो हमने इसको कनेक्ट कर दिया थ्रू 7 and 11. And rest diagram is the same. It is to be noted that according to the Kleen's theorem, if a language can be accepted by a finite automata, then there exists a transition graph accepting that language. Since an NFA is a TG as well, therefore there exists an NFA accepting the language accepted by the given FA. In this case, these FA and NFA are said to be equivalent to each other. For example, यहाँ पर देखें तो हमारे पास चूँकि ये दोनों लैंग्वेजेस जो हैं वो सेम अल्फ़ाबेट्स को रीड कर रही हैं, सेम रेगुलर एक्सप्रेशन को रीड कर रही हैं, Therefore हम कह सकते हैं कि both of them are equivalent. Another example like this as well. तो चूंकि दोनों डबल ए को रीड कर रही हैं, इस वजह से we can say that they are equivalent. Another example we will see in the next diagram to how to build an NFA equivalent to the following FA. Thank you very much.